Okie dokie. Hello, everybody. Long time no see. It's been, since quarter four, we haven't really met yet. There's been MCA testing and all kinds of other stuff going on. But hopefully that should be finished up and we will kind of get into, I'm not going to say a grind, but get into a routine for the rest of the year. So with that being said, we haven't met in a while, so let's just review Schoology, just kind of updates where things are at. Okay, so normal Schoology page. All right, keep checking that pacing guide. Again, that's really going to help you. If you're not sure what to do, or if you're falling behind, keep checking that pacing guide. We are finishing up Unit 10, so we really haven't met all throughout Unit 10. So I'm going to try my best to review some stuff. But then it's really gonna be some time to practice. And yes, of course, let me know if you have questions, concerns, comments. The mid quarter is on Friday tomorrow. It is for again in my class in math. It is okay to turn stuff in after the mid quarter. That may be different in other classes. So make sure again you ask whatever teacher you have if they'll take work, whatever. But it's okay in my class to turn stuff in after the quarter. Okay, let's see here. So yes, we've been working kind of on exponential and logarithmic functions. They are definitely related to each other, and they're sort of like conversions and different things that we can do with them. So we're gonna kind of just I'm gonna go over the sort of review kind of activity, and then I'm gonna let you guys get a lot of practice. So let's see here. Stop sharing and share my iPad. Boom. Let's go. Oh, I forgot. Today is Thursday, May 4th. So it is Star Wars Day because May the 4th be with you. Um, so I don't know if there's any Star Wars fans in here, but that's kind of a interesting thing about today. First and foremost, you kind of got to know what the base functions look like. So again, exponential growth is going to be increasing. Exponential decay is going to be decreasing. Notice these B values here. Okay, my B value is bigger than 1. My B value is in between 0 and 1. Logarithmic function, kind of a similar look, slightly different, but again, when my B value is greater than 1 versus when my B value is in between 0 and 1. Try to just scroll down so you can see. So looking at the top left in the table here, solving an exponential function. Again, I've got my variables in the exponent. That's kind of where I am having an issue. So what did we decide to do? We said, hey, we're going to rewrite 9 as 3 squared. So if we rewrite 9 as 3 squared, now that we have the same base for both of these exponents, they can kind of like cancel out. And all I'm left with is x plus 1 equals 2x. And eventually you end up getting x equals 1. Kind of a similar idea for logarithms. So maybe we can look at them both at once. But you notice, hey, I'm going to take my properties of logarithms and I'm going to say, all right, I have a log base 2 and I have a log base 2 on both sides of my equation. I can go ahead and they're going to cancel each other out. I can kind of drop them out. And then I just solve this like a normal algebra problem. If each side cannot be written using the same base, then to kind of undo this, you use a logarithm. So exponential and logarithms kind of are like inverses or opposites where they sort of cancel each other out. So 6 to the x equals 15. Log base 6 of 6 to the x equals log base 6 of 15. Again, because I have this base of 6 and 6, it cancels out, and I'm left with because I have to divide by 6, I get log of 15 over log of 6. Definitely going to need calculators for these operations. And what did I do on the sort of logarithm side? I basically raised it to a power of 5. So 5 with an exponent of log 5. And they're going to end up canceling out. But again, anything I do on the left, I have to do on the right. So I raised 5 to the 2 and got 5 squared and then subtracted 1. So again, that's just real quick sort of ideas. Graphing exponential growth functions. Okay, again, I do ask you to graph. Here's common mistakes I keep seeing. Okay, people are not drawing the X and Y axis. People are not labeling their units. People are not marking points, and people are not writing asymptotes. Okay, you've got to include that stuff if you want full credit. And you also usually have to ask for the domain and range. So again, whatever you say, your graph has to match. So if you say the range is greater than 1, but your graph goes below 1, that's not that's not accurate. That's not sort of leveling up. So in general, kind of like we have rules, right? We have translations, we have shifts. So for example, if the parent function is 2 times 3 to the x, the blue graph, I can -2, it's like opposite. So this is going to shift my graph left or right. -2 moves it to the right. And adding 3 at the end shifts it up or down. So adding moves it up 3. So I'm going to take, this is basically the same graph, but every single point's going to move 2 to the left and 3 up. And so when I ask to graph the parent function and the new function, this is kind of what I want to see. I want to see 2 points on the parent function translated correctly to 2 points on the new function. Exponential decay functions, again, kind of similar. Got a smaller value that with my exponents, but it works the same where, hey, if this is the equation +2 in my exponent and then subtraction 2 on the end, this is going to move it because it's opposite, left 2, down 2. So when I go and write this in, again, I can see, okay, I took my parent function, the blue function, I moved it to the left 2, and I moved it down 2 for each point. Then we talked about E, okay? So we can do a lot of things with E. One of the things we can do is calculate, it's used to calculate like interest, compounding interest. It's used for population growth. So there's kind of like some real world applications with our fancy natural base E. But just again, the roles kind of work the same. The rules kind of work the same when you shift the graphs. They're all very similar. It's just about finding that that initial sort of difference or that parent graph and then applying it to the parent graph. Okay, and then we kind of talked about some of these, but like evaluating, you can do it by hand and you can use your calculator depending on how it works. So for example, log 125 to the fifth. Well, 125 is 5 to the third power. So I would rewrite this as log base 5 to the third power and then have 5 as well, because when you write it in this as the same base with the number, it's going to cancel out. So again, looking at things to rewrite, kind of the same idea here. It would be 5 to the fourth power. 125, fifth power, fourth power. Okay. So again, just looking at these different couple examples here. What power gives 625? 5 to the fourth. So again, we can write this like it equals 4. This is what I was talking about. 125 to what power gives 5? Well, working opposite, 1/3 would be 5. So this is going to equal 1/3. 10 to what power? Again, thinking about okay, I'm moving every time I multiply it by 10, my decimal place moves one spot over. So I end up getting 1, 2, 3, a -3. And again, with negative exponents, your number's getting smaller, which means your denominator is getting bigger. So the bigger the denominator is, the smaller the number is. Just want to look at this example again with properties. I know I'm going really fast and we have a lot of stuff, but we haven't met in like 4 weeks. So I am trying to just quickly brush through the ideas and then get you some practice. So two things you got to be asked to do are expand and condense expressions. And again, using properties. So of my log, if I see division, that corresponds with subtraction. Okay. And then anytime I've got an exponent out front or in my sort of log number, I can move that number out front like is seen right here. I can get rid of that exponent and we want to do that. Right here, I see I've got multiplication. Multiplication, I can split up and use addition. So this is like saying log 5 of 6 plus log 5 of, what just happened? Log 5 of x. So applying these different properties to manipulate the expression. Similar but different is condensing. So I'm working backwards. I'm saying, okay, I could probably move this into an exponent. Oh, I see subtraction. That probably means division. Okay, so that's my first step, is to get rid of the 3 out front, move it to the exponent. Then I turn 8 to the third divided by 16. And hey, I can actually simplify that and get 32. Now there's lots of strategies to solve them. Again, one of the easiest, again, how exponential and logarithms work is they cancel each other out. So if I have an exponential function, I put it to that log base and it cancels out. But everything I do on the left, I do on the right. I have to do it throughout both of them. How I would solve this if I don't have a change of base on my calculator is log 12 divided by log 7. If you do have a change of base on your calculator, you could just type in log 7, log base 7, 12. Opposite but similar. If I have a log and I want to get rid of it, I need to put it to a 2 and move it to my exponent so that it cancels out. Anything I do on the left, I do on the right. And I'm left with 3x minus 7 equals 32 and x equals 13. Okay. Whew. Mr. Larson needs to stop talking and you guys can get some practice. So I'm going to get it pulled up. I've got 2 of them. We've got a decent amount of time. We'll see how much we get through. Okay, let's see here. Posting in the chat box. Please click that link and we will get started. So we'll probably do this one, I'd say, for about 4 to 5 minutes. And then I do have another one that I'd like you to do as well. So you may not finish. That's totally okay. I'm going to share my screen so those of you watching the recording can see. All right, about one more minute on this one, and then we are going to jump to the other one. Okay, we are missing one person. We're gonna go ahead and jump to the next one. So I'm gonna close that one off. Let's see. Nice work. Overall, pretty good. It looks like pretty good understanding. Number 7. Okay, this was the most commonly missed question. Rewrite 3 to the 4th power equals 81 in logarithm form. Log 3 to 81 equals 4. So that was the most commonly missed question. Here is the other one. Again, properties of logs. We've got a little bit of time. Let's go ahead, try this one. I'll post a new link. Again, we did have one person not click the link last time. Please click the link. All right, just gonna scroll through real quick. Again, the link is in the chat. All right. Oh, okay. Let me see here. I sent it to only Preston. All right, let me. Why is that not working? Yes, I apologize. It has been fixed. Sorry about that. We just did that one. All right, just for the sake of time, again, sorry that I didn't get that link out to some of you earlier. We're going to sort of talk about the Class Connect assignment with our last little 5 minutes here. Again, hopefully you got some good practice. Once you get the hang of these, they're not that bad, but they're kind of like are a new thing. So it definitely can take a little bit of like getting used to. Um, So just a reminder, because again, it has been a long time. Here's where you can find our Class Connect assignments, and we'll talk about them. It's gonna be a folder, Q4 Class Connect assignments folder. And if we look at the first question, it's asking about Newton's law of cooling. So let me run through that quick. There's my stylus. So Newton's law of cooling is a formula. So I've got Newton's law of cooling formula, where I'm going to take my initial temperature, which was 200 degrees, or excuse me, I'm going to take my temperature I want it to end at, which is 100 degrees, equal to my initial temperature, which was 200, and I'm going to subtract the surrounding temperature, which is 75, e to the negative. My rate is negative 0.054. Well, my rate was 0.054, but the formula tells me to make it negative. I'm trying to determine T. I guess we don't need a, but my whole point is to figure out what T is. And then again, TR was 75. So for starters, I'm going to start simplifying. I'm going to subtract 75 and get 25. And then 200 minus 75 is 125. E to the negative 0.054. Again, I'm looking for T. And now to get rid of this 125 multiplied by all of this, that's what that's saying, 125 multiplied. So I'm going to divide by 125, divide by 125, and 25 divided by 125 is 0.2, and then I'm left with e to the negative 0.054 t. And then how do I undo e? I got to take the natural log. So I'm going to take the natural log of e, which is, I'm just going to write it here, basically going to cancel out. But again, anything I do on the left, I also got to do on the right. Well, in this case, anything I do on the right, I got to do on the left. And then my last step here is to divide by negative 0.054, negative 0.054. And when I type in the natural log of 2, there it is, natural log, of 0.2. I'm going to divide it by, I can't quite remember, what was it? Negative 0.054. Where's my negative sign? What the heck? Negative 0.054. I'm going to get 29.8, which when we check the direction says round to the nearest minute, which would be about 30. So again, as I go through, it took about 30 minutes to cool. 2 months ago, you had 3 mice. Now you have 18 mice. How many mice will you have after 14 months? Again, you can figure out what your initial amount is, what your rate is. Considering 2 months, you had 3. Now you have 18, and then your time is going to be 14. And use multiple properties to write as a single log. Basically, condense this function down into one single statement. Okay, I know again we covered a lot we covered a lot because we haven't met a lot. Let me know if you guys have questions. Last thing I had, Cardon or Preston, if you guys want to cover this, or there is a bowling activity, social gathering. I forget what day it is. You guys know off the top of your head, but it's open for all Link 12 students. So if the 10th, May 10th. So I believe it's at the Lakeville Bowling Alley. And so if you're interested, uh, look into that. I believe you can talk to either of them, or is there a sign up for it? I believe. Yeah, go ahead, Cardon.
It's May 12th from 5 p.m. to 7 p.m. and the cost is covered by the Link 12 Student Council.
Awesome. So definitely look into that if that's something, if you like bowling or you just want to hang out. Otherwise, that's all I've got for you. I will see you next week. All good, man.